Day of the third International Humanities Society Identity Congress. Let me introduce to you Professor Robert Małecki, Dean of the Faculty of Modern Languages.
Good morning and welcome everyone. Today I would like to welcome among us Professor Georg Rehm. Professor Georg Rehm works as a principal researcher in the Speech and Language Technology Lab at the German Research Center for Artificial Intelligence, DFKI, in the German. He's also adjunct professor at the Humboldt University of Berlin and deputy spokesperson of the DFKI Lab Berlin. Currently, Georg Rehm is the coordinator of the EU-funded project Language Data Space, coordinator of the EU-funded project European Language Equality, and is involved as a principal investigator in the projects OpenGPT, X Databricks, X Scilike, and NFDI4DS. Since 2013, Georg Rehm has been the head of the German-Austrian chapter of the World Wide Web Consortium, hosted at the DFKI in Berlin. He is also related to ICT and standardization. Georg Rehm is a member of the DIN strategy group Focus Digital, or Focus Digital. Professor Rehm holds an MI in computational linguistics and artificial intelligence, linguistics and computer science from the University of Osnabrück. After completing his PhD in computational linguistics at the University of Gießen, he worked at the University of Tübingen, leading projects on the sustainability of language resources and technologies. Georg Rehm has also extensive industry experience, leading the language technology development at the award-winning internet startup Vionto GmbH, and serving as head of research and AI at the company Field 33. Georg Rehm has authored and co-authored or edited more than 250 research publications. Welcome, Herr Professor. Herzlich willkommen, Herr Professor an der Uni Warschau. Language equality. The floor is yours.
Vielen Dank für die freundliche Einleitung. Many thanks for the introduction. Great, and many thanks for the invitation, of course. I'm very happy that I'm able to speak today at your prestigious conference. And the title of the presentation is Digital Language Equality in Europe, Nothing But a Dream, or Is There a Glimmer of Hope? When my wife asked me last night, what are you talking about? I mentioned the title and she said, oh, that's very poetic. It's not very you. Right, and before I start with the presentation, I want to briefly say a few words about our organization. So DFKI, the German Research Center for Artificial Intelligence, was founded in 1988 by Professor Wolfgang Wahlster. You may know him because he coined the term Industry 4.0 that is everywhere by now. And he had the foresight already back then to establish an independent research center that concentrates on AI research already in the 80s. This is a public-private partnership at DFKI. We do all of AI. We have 29 research departments with about 1,600 employees working round about on 600 projects at any given point in time, with sites in various German federal states, among others in Berlin, which is where I am based. So, a brief outline of my presentation today. I have lots of, just to give you a pointer to contrast this with yesterday's keynote, this will rely heavily on slides. Yeah, I have lots of visual material. First up, I will briefly mention, give you kind of a brief introduction into artificial intelligence, machine learning, language technology, and also large language models. It will be very brief. And then in the main part of the presentation, I will talk about digital language equality in Europe based on the findings of 2 large-scale research projects that I coordinated. And then the key question is, will there ever be digital language equality in Europe? Yes or no? Yeah, our goal was in the previous project to reach it by 2030. Spoiler alert, doesn't look very likely. Okay, but let's kickstart the presentation with AI, artificial intelligence, yeah, and the related topics, machine learning and language technology. AI, many perceive today as groundbreaking technologies that have only been around for a couple of years. This is a myth, yeah, it's not true. The birth of AI is generally considered to be a workshop at Dartmouth College in 1956. So it's been a minute, as they say. On the right-hand side, I found an invitation letter, yeah, 1956, and they even mention in the invitation a summer seminar on artificial intelligence, or the Artificial Intelligence Project, with really key people who formed the field: John McCarthy, Marvin Minsky, and about 20 others who did the groundwork in our area. AI is interdisciplinary in nature, has a connection to multiple other fields, including computer science, cognitive science, psychology, and many others. And it very quickly became clear that language plays an integral part. When you try to develop a machine or to develop a system whose behavior exhibits a certain amount of intelligence, then you need to very, very soon also think about the role of language and what language is, what it means, knowledge, of course, also. This eventually led to more and more prominence of language and cognition as well, yeah, and eventually to the development of the field that I studied in the early 90s, computational linguistics, and this is generally considered to be the cognitive revolution within AI. Our field, so applying AI technologies, applying computational linguistics methods to language, also to linguistic aspects, is also known as natural language processing, natural language understanding. The terms differ a little bit, but that doesn't really matter for this presentation. Okay, a couple of important milestones to continue with the historical evolution theme of the introduction here. ChatGPT, I guess we all know. It's not the first chatbot. In fact, the very first chatbot was developed by another Berliner, Josef Weizenbaum at MIT, 1967. Yeah, he developed the first chatbot. It's called ELIZA. It simulates or emulates a psychologist. You can ask ELIZA things like, "Oh, I'm not feeling too well today," and ELIZA asks back, "Why is that?" My mother said something, blah, blah, blah. And then ELIZA asked back, "Oh, what did your mother say?" Yeah, so and this chatbot back then, more than 50 years ago, relied on simple pattern matching. Yeah, I tried to identify words like mother, father, dog maybe, and then responded accordingly. So it was a kind of a Taschenspieler trick, yeah, so a sleight of hand that Josef Weizenbaum played. He wanted to show that simple pattern matching that is very, very trivial to implement is able to give you the impression that you're interacting with a human being. Highly important work. A couple of years later, Terry Winograd developed Shridlu, a symbolic knowledge processing machine, way more advanced than ELIZA ever was, and could do reasoning. Yeah, it operated in a blocks world. You had red blocks and blue blocks, and you could put one block onto another, and then you can ask the system questions, where's the red block? And then it could say it's on top of the blue block. Fascinating. Back then, yeah, it was groundbreaking. Again, in the 80s, Psych was developed. Doug Leonard, also a visionary in our field, he said, okay, we need to develop a knowledge base, a machine-readable knowledge base, and he picked Encyclopedia Britannica, and Psych is short for Encyclopedia Britannica. We need to encode the knowledge included in these 2 meters of books. Yeah, we need to encode this knowledge using human experts who write logical rules, and he tried to do this. It was a 10-year project with hundreds of people. One group says it failed spectacularly, the other group says it was amazing. The truth is, as always, in the middle. It generated lots of insights into knowledge engineering, how to encode knowledge, and also has some fascinating scientific results. And roughly at the same time, recurrent neural networks were discovered and developed, but back then we didn't really have the machinery to apply them. But theoretically, it was clear they can be used, but difficult to apply. And then in our field, in computational linguistics, it became clear that we need to do more statistical methods, no longer writing rules by hand. So statistical methods were all the rage in the 1990s, early 2000s, when more and more machine learning methods were also applied. So a turn from symbolic methods to statistical methods and machine learning methods. And then about 15 years ago, another turn to neural methods and neural networks based on this paper that I mentioned here on the slide, Tension is All You Need, which changed our field completely. So AI, as I mentioned, consists of depends on how you want to count, about 30 different subfields or sub-areas, including robotics and knowledge representation, human-machine interaction, planning and search. Also machine learning, it's one of the 30 fields. And this, as I mentioned, really started to take off in the early 1990s and went from very simple approaches, very trivial approaches, to large-scale methods for which you needed really large amounts of data, and then to neural methods which require even more data. Data is by now everything. You need data, and you need very, very fast supercomputers to do something with the data. One important breakthrough that I guess you all know happened in 2006. SMT is short for statistical machine translation. Machine translation, one of the holy grails of our field. How can we develop methods and machines that really can do automated translation flawlessly, like a human would? One of these methods was applied at Google. Google Translate was published overnight in 2006, and suddenly in the web you could read Al Jazeera in your own language. What a moment, yeah. I still remember that to this day. It was amazing. And that team at Google is still improving on the software, on the system to this day, and other methods, similar methods are used by many, many other companies. The best machine translation system is DeepL, based in Cologne in Germany, currently. So, and later on, as I mentioned, with the Attention is All You Need paper, neural methods were developed and further developed and fine-tuned and further developed. And this is the area that we call deep learning. So in these technologies, because they are so capable, so great, so powerful, they dominate the whole discussion about AI. So all the other subfields like planning and search and robotics, they are a bit driven to the sideline, because this discussion about ChatGPT and large language models dominates everything, including many myths and also dangers and also many misunderstandings. So this is just a rough example how it works. So we have lots of data. We apply ML methods, machine learning methods. We find certain patterns automatically in an unsupervised way with the machine in the data, and then we have something that exhibits a certain level of intelligence. So the main ingredients here are very large data sets. We need very capable machine learning approaches and really fast hardware, many GPUs, not CPUs, but GPUs, graphical processing units that are very, very good at doing math. And when I say many of these, I'm talking about thousands. You need thousands of GPUs, maybe tens of thousands. And in Europe, we have a number of machines that can really do this in a fast way, but not many, about 10, maybe 12, that are really capable of computing these large language models. Just to give you an indication what kind of technologies I'm talking about here. Named entity recognition is one of them. Yeah, so identifying names, person names, organization names, geographical names in text. Sentiment analysis, yeah, you take a text, you want to process the text, and then you want the machine to say, okay, this is a positive text or a negative text. This can be even done further advanced. Yeah, positive text about what? Yeah, positive text about a certain, I don't know, laptop computer. Okay, this can be even more advanced. Yeah, positive about the display of the laptop, but not about the weight. That's negative because it's heavy, and many other things. So you can drill down into these aspects that we call information extraction, where you want to identify topics in a text and then aspects and certain facets of certain objects, and you want to find out the sentiment of the speaker or writer of the text regarding a certain object. This is sentiment analysis in a sentence. Semantic search, of course, yeah, interactive storytelling, creative writing. ChatGPT can do many of these things, but of course it's not the only application that we are talking about here. Right, so ChatGPT is a large language model. I want to focus on this for a few minutes because it's crucial for the rest of the presentation. So, large language models provide unprecedented capabilities in our field, in our area. They essentially are the state of the art in mostly everything we do in our field, which is computational linguistics. Yeah, so if you look at certain benchmarks and evaluation data sets for tasks like question answering or named entity recognition or whatsoever, yeah, large language models define the state of the art. ChatGPT is one of them. The predecessor was GPT-3. There's GPT-4, Claude, Gemini that Google produced, and many, many others. And they are trained on vast amounts of data. And when I say vast amount, it really is a lot. Yeah. So we had a case where we wanted to train a language model on a supercomputer, and the storage unit in that supercomputer was too small. Yeah, it couldn't handle the data that we had for that case. It was in the order of 10 petabytes. So that is a sizable amount. And this is not only language data, like data crawled from the World Wide Web, where you send out a crawler to crawl all the hyperlinks, and then you collect the pages. While the crawler goes on, collects more pages, you store them, and so on, which typically generates billions of web pages, which you can then process to generate the data that you train your model on. Text data, yeah. So you can also include image data, audio data, video data to do multimodal models. Yeah, they are no longer language models, but multimodal models that have in one representation room language and audio and video and others, which is fascinating. And essentially, all these AI image generators that you see online, capabilities of ChatGPT, where you draw something onto a napkin, you take a photo, give it to ChatGPT, and ChatGPT can then build a user interface based on your scribble on the napkin. This is due to its multimodal capabilities. Very difficult to develop, actually. And in Europe, now coming to the European situation, yeah, in Europe we have multiple languages. And the situation with multiple languages and the multilingual setup in Europe makes everything much, much harder because of the data imbalance. Yeah, it's probably intuitively clear that there's lots more data for English than for, let's say, extreme example, Irish, Maltese, Latvian, Lithuanian, Ukrainian. Yeah. So what do we do here? So at the same time, we have a trend to larger and larger language models. Yeah, more data, more parameters, more compute. Why? Because larger models simply perform better, which is due to scaling laws. At the same time, we have unprecedented economic opportunities. There are many forecasts that say the global market in this space will reach $440 billion by 2030, or the Gen AI market will be $1.3 trillion by 2032. And there are many more of these. The numbers are mind-blowing. And this is something that I also work on here, the European Union and countries in the European Union, the member states, really need to step up their game and coordinate more to be competitive. So let's very, very briefly look at how language models work. Very briefly. No math, I promise. So language models, what do? They do one thing, and one thing only. Footnote, slight simplification. Yeah, it's not entirely true, but mostly true. So they do word prediction. They predict the next word. Yeah, so a language model is a probability distribution over sequences of words. They are computed by algorithms that take these massive amounts of data. The language model is being trained. Yeah, the model is a probability distribution over word sequences or token sequences. We call words we call tokens. The number of parameters kind of indicate the size of the model in terms of, let's say, knowledge, in air quotes. And then training such a model can take months. Yeah, even on a supercomputer it can take 4 weeks, 6 weeks, 8 weeks, depending on the system setup, on the number of parameters you're going for, and the language data size that you're training the model with. So, and what does it do? Here's an example. Alice painted her house, ... So, and then the language model can output the next word, given a certain probability based on this input sequence. So, and here we have a couple of examples. With this example, brown is the most likely word, 20%, or beige, red, maybe because, or with a brush, perhaps. This is the basic functionality of a language model. And the nice thing is that it translates to other applications, or two applications, yeah, because predicting the word is not an application. So this next word or next token prediction can be perceived as a general purpose task. So, for example, for question answering. The Eiffel Tower is located in ... And then you would expect Paris. But there's also a replica in I think, Las Vegas, and there's another replica in China somewhere, edge cases. Translation. Yeah, the house is wonderful, German translation, ... Das Haus ist wunderbar. Summarization, the Eiffel Tower is a wrought iron lattice tower. TLDR, that's net speak for too long didn't read. Yeah, give me the summary, TLDR, and then you can get the summary of this article, or even to math. 3 + 10 equals ... So benefit here is that we have one single general purpose model instead of multiple specialized models that do only one thing. So you've maybe heard about the size of language models. They are getting larger and larger. They use more data, more parameters, more compute, but they are also getting better at the same time. This is a very old slide. The most recent models are somewhere in the stratosphere, yeah, if we take this slide here as an example. This has downsides, of course, many of them. Yeah, compute is very expensive, not only in terms of electricity, but also for the environment. Yeah, many people are working on reducing the impact, the carbon footprint of language model training, which is why there is now even a trend to smaller models again. Yeah, so instead of brute force training trillions of parameters for half a year, which would consume, I don't know, the electricity of North America, combined, people are now looking more and more at smaller models. That penny has dropped, fortunately. But there are also people, especially people from industry, from the big tech giants in the US, who demand setting up more nuclear power plants just for this purpose, yeah, which is insane if you ask me, but that's just my personal opinion. I'm happy that the German government decided to scrap them. Okay, so yeah, this is mostly it, just a couple of additional things. So the model parameters roughly correspond to the memory of the language model, also to the context length, which is important. So how much context you can put into your request, into your prompt. But generally, it's still true that the larger the model in terms of parameters, the more memory it needs and provides, and the more training data it can take in to store more knowledge. And typically, larger models outperform smaller models. And as mentioned, yeah, colleagues are now working on reducing that gap as much as possible. Yeah, so that a 7 billion parameter model, which is small, yes, it is being outperformed by a 70 billion parameter model, but only a little bit. Yeah, so and maybe this reduction in capabilities, maybe that's okay for most purposes, if we can save the environment. Okay, in order to build something like ChatGPT, we need to do a bit more downstream. So first of all, if we have a language model, let's say, and we have something like a user question, where's the Eiffel Tower located? The user expectation could be, it's in Paris, France. But a pre-trained model may simply respond with another question, like you ask where's the Eiffel Tower located, and it responds with how tall is the Eiffel Tower, which is not what you want. Yeah, instead you want Paris, France, short and crisp. So and what you can do is you can fine-tune language models with additional data so that it follows instructions, such as here in this example, answering simple questions, writing small pieces of text, or performing simple operations. This is different from following dialogue or behaving natural when in a dialogue situation. So here we have something like a user prompt, where's the Eiffel Tower located? And an instruction model could say Paris, France, but maybe that's not what I want. Maybe I want the model to respond with a nice little text, like in the top right or middle right part of the slide here. Yeah, like Wikipedia style, a short explanation where it is. Yeah, I will leave it here. So in addition to just having a large language model, yeah, that's not ChatGPT yet. You need to do more. You need to do instruction tuning, and you need to do dialogue fine-tuning, but you need even more. This is a simplified chart of what we think the people at OpenAI do when they develop systems, because we don't know. They don't do open science. Unfortunately, as a business owner, I would probably say, yeah, tough. We don't do this, which is okay. So people in our field are now trying to guess and reverse engineer what OpenAI is doing when they build their systems, and other companies in this field. And this arrow here is pointing at a very, very important part, and that is human feedback. Yeah, so humans judge and evaluate the output of the model when it's still being developed, and they say that's a binary classification. This is a good response. This is a bad response. Good, bad, and so on. And so the human component, the human factor, is still very, very important. It's not really clear how many people OpenAI hired to do this kind of human feedback training, which generates another model that is being used in conjunction with the original model, but that's maybe too much technical detail. But humans are indispensable for this task. It's not just an AI. So before I now come to the main part, I want to briefly talk about data distribution. Yeah, so language models are trained with web data typically. Lots of the data in the training run is web data. But we can also use other kinds of data, like book data, Project Gutenberg, for example. But this is only tiny. It's tiny amounts of data, just a few megabytes compared to petabytes that you can get from the web. Web data is diverse. There's all sorts of stuff in there, as you know. It's definitely not balanced or representative of all the languages we have. It's also rubbish, yeah, in terms of quality. You have lots of noise and stuff that you don't want, like bias data, maybe propaganda Yesterday in the keynote, I liked that very much. The crisis of truth is something that bothers us a lot. Yeah. So who defines the truth? It's surely not a ministry of truth, but some people still like to proclaim alternative facts, and this is a real problem for our field and also for humanity, as we currently see and experience. But this is maybe for another talk. On fake news detection and bias detection and the crisis of truth and AI. Programming language code is also part of the training data. Yeah, so and many people think that it's programming language code that is just being used like all the other text. That's treated on the same level. And some people say that these great capabilities of language models are due to the programming code, which we still need to find out. The jury is still out here. But one key finding here definitely is that the data sets are not balanced. Yeah, data sets are not balanced at all in terms of languages. So if we now look at the European situation, and this is a couple of slides and findings from a project called MetaNet that I have the pleasure to manage and coordinate about 15 years ago, where we wanted to look, and this is pre-language models, pre-ChatGPT, pre-all that stuff that we all now use and like and talk about. We started that project with the observation that we have a European multilingual information society. Multilingualism was and still is at the heart of the European Union and the European idea. All languages are equal, which was a great idea, great principle that they put into the EU treaty. So not one language was better than all the other languages. They were all the same, which was a good decision. In addition to the 24 official EU languages, we have dozens of regional and minority languages. We have languages of immigrants and trade partners and so on. And this situation creates challenges, social challenges, technical challenges, digital single market needs to be multilingual, and so on. And back in 2010 until 2013, we had MetaNet. We had follow-up projects like Cracker and European Language Grid, and most recently, European Language Equality, that wanted to find out what can we do so that every person in Europe can enjoy speaking their mother tongue and being supported through technologies for their own language without being enforced or forced to fall back to English or Spanish or maybe French. Maybe I want to use the systems in Welsh or in Latvian or Lithuanian. So that was undiscovered, uncharted territory, as they say. And we did many different things in this huge project. We wrote strategies and recommendations, and we had many, many conferences, and among others, we created these around about 10 kilograms of books. We call them books, they are more like booklets. 31 of them, 31 books. We call them MetaNet white papers, and each book reports on the technology support for one European language, written by the experts from that country and that language. And the report is in that language and also in an English translation. And then we took these 10 kilos and we shipped them to the European Union, to the European Commission, and said, we have a problem. What is that problem? Yeah, the problem is we sat together in many, many meetings and we compared languages, we compared applications and data sets, and this was more or less like an intellectual task. And we came up with this chart here, with this comparison, where we tried to sort out which languages belong into excellent support, good support, moderate support, fragmentary support, or weak or no support for these 4 different application fields here: machine translation, text analytics, speech, and language resources. And turns out no language has excellent support, which would be roughly comparable to human level competence. Good support only for English, moderate support just for a handful of languages, and then fragmentary or weak support for most of the other languages. Devastating results. So we can look at this chart here, which shows this in a graphical way, equally disturbing, the result. Yeah. So clearly our political situation is that the languages are treated equally and they have equal status, but technically the opposite is true. We, as mentioned, we organized many conferences. We tried to raise awareness in Brussels and Luxembourg at the European Commission. We had workshops in the European Parliament where we talked about this. Studies were commissioned and written. They confirmed our findings. Surprise. And then pretty much nothing happened. And then in 2018, another Welsh person, coincidentally, Jill Evans, member of the European Parliament, she spearheaded, because she wanted to use technologies in her own mother tongue, she spearheaded this resolution in the European Parliament called Language Equality in the Digital Age, and that this paper recommended that we need to establish a large-scale, long-term coordinated funding program for research and development and innovation in the field of language technologies, tailored specifically to Europe's needs and demands and catering for all European languages. Great. Went through the Parliament with a landslide vote of 592 yes votes. So that was our findings back in 2012, 2013. Before I continue with our findings from our most recent project, European Language Equality, I want to very, very briefly do a short detour because you need to understand how we computed the numbers. And we computed the numbers based on this system. The system is called European Language Grid. It was developed by a European project that I coordinated a couple of years ago, and the European Language Grid was meant to be established as a community platform for our research field, so for natural language processing, not only academia, but also industry. That was a very successful project. By now we have about 1,400, 1,500 users in the system. We have about 18,000 different resources in the system. What is a resource? A corpus, a data set, a tool, software. What else am I listing here? Lexical, conceptual resources, language models by now as well. And this is all documented in a book, which is available open access if you're interested. This is what it looks like. So you can have a graphical interface, a web interface, and you can use the language grid to explore in the catalog, okay, I need a named entity recognition data set for Faroese. Does it exist? And then you can check if there is something that fits your need. You can also test different tools online in the system. Bottom right hand side, that's a dependency parser for the English language. I think that's a Martin Luther King example. So this is a very handy system with lots of information about language resources, language technologies for our languages. So this is the development of resources and different types of resources per category. And this is what we take as our ground truth for computing the language technology support for our languages in our most recent project. Right, and I think I need to hurry up a little bit. Before I go to these results, one aspect, as I mentioned, we need to, not only do I need to hurry up in my talk today here, but also Europe needs to hurry up when it comes to spending more money in the general area of AI. This article here in the Washington Post was published after ChatGPT was published. And it shows just how far Europe lags in tech, and it's still true. There's still no fully capable ChatGPT competitor in Europe, built by companies in Europe. Some have tried and failed, and we need to do something about this. But there is another glimmer of hope here. So there are many initiatives. We have many companies working in this area. Like Silo AI in Finland, Mistral in France, Aleph Alpha in Germany. We have research projects in almost every country working on their own language models for their own languages, which is great. We have EU projects. Soon the Commission is starting the AI factories, which will connect companies with the supercomputers that we have in Europe. Data spaces are meant to provide the data for these activities, for the data economy, and so on and so forth. Yeah, so the first glimmer of hope, small one. And most recently, in 2021, we started a project called European Language Equality with 52 partners from all over Europe. And now we wanted to see if the MetaNet results from 15 years ago, if they still apply, or has the situation changed? And if so, in what regard? One key element that we implemented and developed in this project was something that we called the digital language equality metric. Yeah, we wanted to have a clear formula, a documented open science kind of way formula that clearly specifies how we come to our results, how we arrive at our results. And for this, we used the ELG catalog. Yeah, 18,000 resources. We can just put them in there and then compute the numbers. And this is still possible today. This is the key foundation of our work, documented in many, many project deliverables and also scientific publications. So what is digital language equality? That's, and I'm quoting here from our papers, that's the state of affairs in which all languages have the technological support and situational context, which is important, necessary for them to continue to exist and to prosper as living languages in the digital age. Yeah, we debated this definition a lot, yeah, but this is, you can see the issues here, but this is something that we agreed upon. This is what we want to achieve. And this digital language equality metric is a measure that reflects the digital readiness of a language and its contribution to the state of technology-enabled multilingualism, tracking its progress towards the goal of digital language equality. And here we are looking at two different things, yeah, let's say two different buckets of data. On the left-hand side, technological factors, like how many corpora and data sets exist for a certain language. Are there domain-specific corpora, which are very important for application development? What are the licenses? Are they available only for 100,000 euros per license? And there are examples that, yeah, it's clear when someone is required to make data available for a project contract or due to a project contract, and then the price tag is 100,000 euros, then it's clear that they don't want to make the data available. Yeah? These cases exist, many of them. What's the coverage of the corpus, and so on. So these are clearly countable technological factors. And on the right-hand side, the context, yeah, the social-political context of a language, for example, regarding the economy of the country or region where that language is spoken in, the size of the economy, do they have language technology, AI, NLP companies, and so on. So, and this is the result this is the June 2022 result. The arrow is pointing at Polish. So it turns out that except for English and to a certain extent German, Spanish, and French, all European languages are massively under-resourced in terms of data, tools, and technologies. Yeah, you can look at the bar at the very left. English, it's clearly the highest bar. And then there's a very big gap, and then we have our trio of German, Spanish, and French. And then another big gap, and then the rest of the languages follows. Okay, disappointing, but this was the result. We can also look at the deltas between 22 and 23, which is even more disappointing. Yeah, the gap is growing instead of getting closed. So the gap is getting bigger. So let's look at the contextual scores, and this is somewhat reflecting the social political ecosystem in which a language is spoken. And we did a similar graph of the GDP of a country, and they correspond a lot. This is also due because the GDP is a very important factor in this formula here. But it's also clear that many of the languages that are here yellow, yeah, the regional minority languages, many of these languages simply don't have a chance because these languages are not supported by their regional governments, for example, in terms of technology support. And excellent exceptions, Catalan, Basque, Galician, yeah, excellent examples because their regional governments are investing in these languages, and there are great technologies for these languages. Yeah, and I could mention now many anecdotes. Icelandic, for example. There was, back when I started with this whole field 15 years ago, there was one person in Iceland, one person working on these topics. Yeah, and he was already getting close to retirement, but he was still passionately working on technologies for Icelandic. Now there's a growing group of companies in Iceland working on technologies. Why? Because the government invested for Icelandic standards an enormous amount of money, about 20 million euros, into data collection, into apps. Yeah, so every person in Iceland can provide data samples, language samples of them speaking Icelandic. So Icelandic is now still very much under-resourced, but there's now much more available for the Icelandic language, which is fantastic. And if you're interested, you can go to the European Language Grid. You can create these graphs on the fly and automatically reflecting the current state of play of the metadata database that we have in the European Language Grid. Right, and you can use this dashboard that we developed also to really drill down into these languages, how they do in terms of technology support. I want to briefly show you some examples. Yeah, we did this on a slightly different database. We did this earlier just to see how we present these findings also in the web interface. And here we divided the languages into the official EU languages in the top half of the table here, and then other languages, regional languages, and so on in the lower half. And we categorized them into good support, moderate, fragmentary, and weak or no support. And this is based on a data set of 11,000 resources. And we can see a couple of things, yeah, just to pinpoint a couple of findings here. Translation technologies. Many languages are at least moderately supported, which is good news. Multimodal corpora, very weakly supported throughout all the languages. The EU official languages are doing much better than the non-official EU languages. Probably not a big surprise, but an important finding. Best supported, I mentioned this, English followed by Spanish, German, and French. Least supported, Irish and Maltese. In Ireland, some colleagues are working at DCU, Dublin City University, on these topics. Malta, a tireless team of, let's say, 5 people, 4 or 5. So that's the situation. The best supported among the languages with official status, but not official EU languages, yeah, Norwegian, Icelandic, Serbian, Basque, Catalan, Galician, and Welsh. You can also select certain languages and then create these radial graphs here, which I find very interesting because they hammer down the problem visually. Yeah, so here we have a comparison between English and some other languages, and the disproportion here becomes obvious in this kind of visualization. Or here where I compare English with German and Finnish, and then Southern Sami or Faroese or Northern Sami, and it's clear that there is an issue here that we need to address. We also asked ourselves the question, so what languages are people in our field actually working on? Which is discussed quite a bit of time. Many colleagues in our field, they work on English. Yeah, they are German natives or Polish natives or what have you, but they still work on English. Why? Because they want to produce their results in a language that other people in the field understand. Yeah, so yes, English is the language of research and of science, but here English is also the object of that research, so that you can compare yourself with your colleagues globally, which is a problem for these languages that are suffering because they are not addressed. And that's exactly the case. Yeah, we did a bit of text mining in a paper repository, papers from our field. the ACL anthology with, I think, something like 60,000 papers on natural language processing. And you can see the results, yeah. The majority of papers is working on English, and then we have German and French and Spanish, Italian, and so on. Polish, about 500 papers, great. And there are many colleagues in Poland working on syntax and lexicography and so on. Many of these are also counted here. We can also visualize these in a nice way. So here comparing NLP tasks and domains, English on the left, German in the middle, Polish on the right, and we can see that there are many gaps that can be addressed. So, and all of these different findings we put together into a strategy paper informed by more than 2,400 pages of condensed findings. We took 92 different languages into account. We wrote it all up. We published another book. We presented the book in Brussels. We sent the book to many people. We had more conferences. I did quite a few presentations in the European Parliament with the European Commission, and then eventually nothing happened. Yeah, nothing happened. We were a bit sidelined by AI and the AI development, which overtook everything. Yeah, so suddenly our topic was perceived as, this is just a little thing in AI, which is not true. So, to conclude, slowly but surely, will we have digital language equality in the year 2030? Right now, it doesn't look good. I want to just briefly mention a few, and I will do this now in a fast-paced style, I guess. I will just mention a few activities that we do at DFKI in Berlin, also at other sites in DFKI, to address all of these issues. OpenGPTX is a German project that was the very first nationally funded project for the development of a German language model. And we just released, a few weeks ago, we released the very first iteration of our novel model called Teuken. Also in OpenGPTX, we created data sets. Yeah, we like our acronyms. This one here was OSCAR. Still available, it's still being worked on. OSCAR is a kind of a processed version of Common Crawl DUMS. What is Common Crawl? The Common Crawl Foundation crawls the web. They produce web crawls on a monthly basis, and this data is, you cannot really work with the data as it is. So you need to process this, you need to clean it, you need to filter out all the, OSCAR, all the rubbish and the garbage to come up with a clean version of the data. And recently we produced 2 big data sets, Colossal OSCAR and Community OSCAR, with hundreds of terabytes of data. We are not ignoring the linguistic corpora. They are very, very important, even if they are only small. Yeah, so compared to web crawls, they are the proverbial drop in the ocean. But we also developed a software framework called LLM datasets, in which we included more than 400 traditional corpora produced by linguists and computational linguists as additional quality data for language model training. And here we collaborated also with our colleagues from the European Language Equality Project. We worked on methods to reduce the training effort needed to bring down the electricity consumption, which was very successful in this experiment here, where we have been able to reduce it by 80%. We have experimented with chat interfaces and with retrieval augmented generation, which is a very important part right now, essentially to bring in, to address the crisis of truth, to address, to bring in facts from knowledge bases that you know are true, whatever true means. We've also started an initiative called Otziglot. If you're interested, you can participate. Yeah, it's a group of by now 400, 500 people, loosely organized through a Discord server, who want to change the situation, everything I addressed in this presentation today. Many people are working on many different languages. They provide data, they do training experiments, and so on and so forth. I think I will skip the details here because they are maybe even a bit too fine-grained. So, but this is a very, very crucial slide. I want to spend a few minutes on it. So I mentioned the language situation, which is really not ideal, which is due to the fact that we have too little data for these languages. Yeah, we need more data for essentially all our languages, and we also need to change the whole approach at collecting data. It can't be the situation that we simply have to rely on web crawls, where the Common Crawl Foundation, which is an American foundation, by the way, where an American foundation makes available web crawls that we then have to sort through and process. Not ideal. But maybe a good situation could be where even smaller amounts of language data are enough. Yeah? So by now we know that multilingual models, many language models are trained with multiple language data, data in multiple languages. And in some cases, you have only very, very small amounts of data for a certain language, yet the model is capable of speaking that language fluently. Yeah, it can produce language, or it can produce sentences and paragraphs in that language, even though that language was only represented in a tiny way in the training data. And this, we still don't know exactly how much data is needed, what type of data is needed, which other languages you need. Do they need to be typologically close to that language or distant? This is still something we need to work on. Yeah, but this is something that could be an off-ramp for many of the under-resourced languages if we find out more. And then maybe small amounts of language data are also okay to produce a language model that is capable of providing excellent output in Welsh or Latvian, Maltese, Irish or Lithuanian. So, but still, we are running out of data. All the companies are running out of data. And it was already briefly mentioned in the introduction that the European Union is now trying to set up data spaces. One of these data spaces I'm happy to coordinate, that's the language data space. This is a procurement project from the European Commission. The European Commission wants a language data space deployed throughout Europe to do pretty much what I just explained. Yeah? So we want to collect language data from companies, from industry, from those organizations that have lots of language data, which we right now don't have access to. We know that data exists, because these companies exist. And libraries have lots of data. Broadcasters are my typical example, my favorite example. Public broadcasters, they are sitting on treasure chests full of audio-video data, podcasts, maybe radio stations. If we had access to that type of data, we could do many, many more things in Europe. And this is our vision in this project. I don't want to go into the details. It's a decentralized infrastructure. Every participant can set up their own little connector to this data space. They can decide which kind of data they want to make available, under which conditions, with which licenses and policies. And this is what we are currently doing with many colleagues in Europe. We are talking to them. We are trying to convince them to participate, to do something for the situation regarding European languages. So, short reality check, and then I will conclude. The reality check you can see on the slide here. These are press reports. I mentioned companies, even by name, OpenAI, Microsoft, Google. They all need data. They are all looking for data. They have very deep pockets, and they can pay 50 million, 60 million for a data license for 1 year. So just to compare this, our project, our charming little language data space project is 6 million euros for 3 years. But this is the reality. So, and we are now trying to develop a system and kind of a language data economy in Europe with our project that is able to at least to compete technologically, effort-wise. But it remains to be seen if we can develop an economy for language data that will reach these price tags. It will take some time. It's a pretty conservative group of organizations that we are dealing with here, and we need to hopefully convince them to participate. So To conclude, yeah, so back in 2012, our MetaNet study, the MetaNet white papers, they concluded, that was our press release title actually, 21 European languages in danger of digital extinction. And then in 2018, we had this European Parliament resolution, the Jill Evans report, that Europe really needs to take action, but still nothing has happened by and large. Our current results show that there's still an extremely strong imbalance in terms of technology support of and for Europe's languages. And essentially, you can say that all languages except English are under-resourced. Why? It's clear, yeah, so there's a lack of data. We need more data for under-resourced languages. We need domain-specific data, yeah, legal data, economy data, medical data, and so on. And also always up-to-date data. This is also very important. This is also where the broadcasters come in. And we have a lack of very high-quality data. But still, yeah, maybe only little data amounts are needed for an under-resourced language in a multilingual language model. This may be as one off-ramp. It's clear that Europe demands and deserves language models that are aligned with our values, cultures, and languages, and what we perceive as the truth, maybe also. And our current goal is to identify and make available very large amounts of new data and fresh data, and also in a continuous way. Yeah? So if we had access to the broadcasters' data on a daily or nightly basis, that would be fantastic. That would be a true game changer for our field in Europe. And of utmost importance here is, of course, adoption and use of the language data space and related projects so that we can get this data finally into our research and into our industrial labs. And with that, I want to conclude. Thanks very much again for the invitation and for your attention. Sure.
If there are any questions, please raise your hand and the volunteer will pass the microphone. Or me.
Okay, I have a question about electric energy consumption and how you were able to reduce it in 80%.
We essentially reused an existing language model for the English language, and we took German data. We aligned the German data, so there's a process involved in language model development called tokenization. Yeah, and we tried to align the tokenization between the two models, and we could make use of the existing tokenization and weights in the English model because they corresponded already to the German data. And this way we just needed to train the model a little bit, but still had a capable model. Yeah, so that was making use of the existence of open source models and then cleverly aligning them with existing data, but for a different language. And then we've been able then to develop the very first, no, that was not the first, but it was the biggest. By then it was, at publication time, it was the biggest German model 2 years ago.
Thank you very much. It was a terrific lecture. I would like to ask a very basic question about what is a European language? I couldn't help noticing that Serbian and Croatian and Bosnian are separate languages, which they certainly would not have been half a century ago. It's the politics that I'm getting at, obviously. No East Slav language seems to figure in your research at all, so presumably Russian is not a European language. But if one day Russian is included in your work, and presumably Ukrainian, of course, as well, and Belarusian, a third East Slav literary language, but international committees have recognized the Rusin language as a fourth literary language in the East Slavic family. And that language is spoken in Poland by a minority. There is a minority here that speaks Ukrainian as well. Same in Slovakia. Would it have been possible to include these minorities inside the European Union in all the empirical work that you've been doing so far? Or are there plans to extend this work in the future? It's really the politics of how we define language that I'm getting at. I think the politics of Rusin are changing just because of the war in Ukraine at the moment, fairly obviously. Some of the scholars who up to now have said we must campaign for a separate Rusin language are now accepting what the Ukrainian nationalists say, that there is no separate language.
Mm-hmm.
How do you view these matters from your angle of AI?
It's very simple. I'm happy that we eventually convinced the European Commission to go beyond the 24 official EU languages even. Yeah. So there was a time about 10 years ago when the Commission wouldn't even fund projects on Basque or Galician or Icelandic, for that matter. Yeah. So and by now they do. By now they recognize these languages as important. They are not strictly saying only the 24 official EU languages count. There are more languages. Yeah, that penny has dropped, and we had to restrict ourselves here. I think Russian is not included here because the European language grid is not focusing on Russian. We have taken into account essentially all the languages that we have in our database. Russian is included. Yeah, maybe it's even in the slides somewhere. I'm not sure. But we didn't artificially restrict ourselves to let's take these languages and these other languages are out. This is not what we did. Yeah, but it's also clear that the European language grid is not the Russian language grid. It's not catering for the Russian language first and foremost. But there are still many multilingual resources in the system that also include Russian data. Yeah. But it wasn't the focus of our research. Regarding Serbian and Croatian, yes, the old story. That's a political distinction. Yeah, even though I know many colleagues in both countries, obviously, and they both say, yeah, that their language is very much distinct and its own unique language. They are both listed here. Yeah, so I don't know if you can. So this is Croatian. Serbian must be somewhere, but it's definitely in here somewhere. Can someone see it? Yeah. There it is, right? Yeah. So comparable in terms of technologies. But at the end, you're right. Yes, it's a political distinction. What is a language? Or it can be also a political distinction. What is a language? What is not a language? And here we try to be as open as possible.
As we know, there are specific spelling particularities between regions, in Germany, for instance. Is there a propensity to standardize spelling so LLM would promote only, let's say, mean spelling of language, which in fact would lead to narrow the spoken corpus of languages?
There are spelling variants. There are also spelling mistakes, simply. Yeah, and all of these variants are. Yeah, it's actually not only a good question, but it's also a tricky question to answer to, because it all depends on statistical probability distributions in the language data. Yeah, and of course, the let's say the primary variant, the dominant primary variant is the dominant variant also in the data, which is why the other variants, the non-dominant variants, are simply subdued in a way in terms of the statistical probabilities. But still, you can retrieve these. I don't know, when you go to Bayerisch or Fränkisch or so, yeah. So these examples, or Schweizerdeutsch, of which there are also many variants, Berndeutsch and Zürichdeutsch and so on. But you can retrieve them by instructing a language model to respond to me in Zürichdeutsch or in Fränkisch or in Bayerisch or in Niederbayerisch, and then you can instruct the model to take these probability distributions into account only for these spelling variants. Yeah, so you can try this in ChatGPT. I'm sure it works.
wanted to ask you, because I'm not sure if I understand correctly. So in Brussels, there's like insufficient lobby, for example, to promote or to like make the public broadcasters of languages to release the data they have, these treasure chests, yeah? So is it a matter of political lack of lobbying for this cause?
In a way, yes. This would probably be another lecture, but there is a separate initiative that has maybe a little bit to do with this, towards the development of a European public space or a European public sphere, which we don't have right now in a digital way. Yeah, so sometimes there are crises in the European Union. The financial crisis in Greece was mentioned yesterday in the keynote, and the situation was that Germans wrote about the crisis, yeah, and Greek journalists wrote about the crisis, and no one was able to talk to each other in a digital way. It would have been nice to have a platform to talk to people in Greece about the situation, and doesn't exist. Yeah, so one group of people in Brussels and also elsewhere, they are trying to get larger amounts of money for developing such a system, a platform, a digital European public sphere, where all of Europe can come together to discuss important topics with one another in their own languages. And in order to build such a system, yeah, we need capable technologies and we need capable language models that cater for all the languages. And one side effect could be that, because they have a very strong lobby, this group I'm talking about, one side effect of this development could be, and also with other data spaces, there's a media data space, for example, with EBU, European Broadcasting Union, is involved, and we are trying multiple different levers and gears to talk to broadcasters and to get them to at least make some of the data available. Yeah, it's a very long game, but we don't have that much time anymore. There's one more question upstairs. No, two, but I don't know if we have time.
I have an important question. What about AI model for classical Latin? Because you spoke about European languages, and what about classical Latin in AI perspective? Thank you very much.
Theoretically possible to develop. Practically probably too little data. Because there's not that much Latin data available. But other more basic technologies like word embeddings or sentence embeddings, they have already been developed for the Latin language. Yeah? So a colleague of mine at Humboldt University, he's working on exactly this for Latin. If you want to look it up, Konstantin Schulz is his name, and he's doing great work.
Probably the last question. Thanks a lot for a terrific lecture. I wanted to ask, okay, imagine you had a magic wand. So what should happen for a speaker of Occitan or Kashubian to be able to open up ChatGPT and ask a question in their own language and get an answer in their own language? So if you had all the possible resources, so what would you do for speakers of those languages to be able to succeed, right?
We debated that question a lot in the project when we thought about the question, okay, how much money should we request from the European Commission for exactly this purpose, yeah, Occitan or any of the other very, very under-resourced languages. What can anyone do with X amount of million euros? Data collection, for example. I think we need to look at the use cases and best practices applied already to, let's say, not only revitalize, but bring languages into the digital age. Icelandic, especially. They had a very good plan in Iceland for data collection, as briefly mentioned. It was all almost gamification kind of way, where you had a nice little app and you could bring in You wait at the doctor's and you can speak into your phone. You collect a bit of data by telling a story, and the data is being collected, and then, in Germany, people would say, Datenschutz, Datenschutz, so my data is going away, or no, everything is going to hell. But they simply did this, and that was great. Of course, it's a very small country, and you can do interesting, innovative things in very small countries. And in bigger countries, it's getting more and more complicated, obviously. But data collection, technology development, you can fund startups, and so on. So there are many different things that you can do. If we have time, happy to take another question. I'm not the timekeeper. So. Okay.
Do you have data security in your picture? Because we have in UN some values, for example, personal data security and development of models in US were more able because there are less regulations, and see what happened with Cambridge Analytica, and how do you want to prevent those situations, and how do you want cooperate with current union law?
So right now the legal aspect and talking to legal experts is taking more than 50% of our time in the project. The short answer is yes. The provocative longer answer is that this is keeping us from focusing on the important things. So, but yes, we take all of this into account. AI Act, Data Act, Digital Markets Act, GDPR are the biggest pieces of legislation that we are taking into account. But I also have to say, maybe this is a bit provocative and subjective. This is taking up so much attention on our end that we don't really have the time to talk to companies, to talk about what they want to do and to deploy the software. But this is maybe part of a European project in this space. But it's a very big part right now.
Okay, thank you very much. I think if there are more questions, Professor Rehm would answer them privately during the very short coffee break we have left. So thank you very much. Enjoy the rest of the Congress.